Assalamu alaikum wa rahmatullahi wa barakatuh. This is a chapter 5 prime numbers part 1. Objectives of this period. Find the multiples and divisors of a natural number. Recognize that the sum of two multiples of a natural number is a multiple of this number. Recognize that the difference between two multiples of a natural number where the first is greater than the second is a multiple of this number. Recognize that the multiple of a natural number is a multiple of this number. Recognize if a given integer is a prime number. Find all the prime numbers less than 100. Materials you will use: your textbook, your copybook, and a pen. Multiples and divisors. Definition: A is a multiple of B means A equals B times K. This means that A can be written as a product of multiplication of B by another natural number, whereas P is a divisor of Q means Q is a multiple of P. A, B, K, P, and Q are natural numbers. Example: we have 3 exponent 3 equals 3 exponent 2 times 3. From this statement we can notice the following. 3 exponent 3 is a multiple of 3 exponent 2. Because we could have written 3 exponent 3 as a product of 3 exponent 2 by another natural number. For the same reason we can say that 3 exponent 3 is a multiple of 3, whereas we say 3 exponent 2 is a divisor of 3 exponent 3. Also 3 is another divisor of 3 exponent 3. Application: answer by true or false the following. Number 1. 5 exponent 8 is a divisor of 5 exponent 6. Number 2. 4 exponent 5 is a multiple of 4 exponent 2. Please pause this video to solve this application. Here are the answers. Statement 1 is false. Since 5 exponent 8 is a divisor of 5 exponent 6 by referring to the definition above, this means that 5 exponent 6 is a multiple of 5 exponent 8. This is false because there is no natural number by which we multiply 5 exponent 8 with, so that we get 5 exponent 6 as a product. Statement 2 is true because 4 exponent 5 equals 4 exponent 2 times 4 exponent 3. Property 1. The sum of two multiples of a natural number is a multiple of this number. Example: 12 is a multiple of 6. 42 is a multiple of 6. The sum 12 plus 42, which is equal to 54, is a multiple of 6 because 54 equals 6 times 9. Application: answer by true or false. If x equals 20 plus 16, then x is a multiple of 4. Please pause this video to solve this application. This statement is true. X equals 20 plus 16. 20 is a multiple of 4 because 20 equals 5 times 4. 16 is also another multiple of 4 since 16 equals 4 times 4. By referring to property 1, we will obtain that the sum 20 plus 16 is also a multiple of 4. Thus x, which is equal to this value, is a multiple of 4. Property 2. The difference between two multiples of a given natural number where the first term is greater than the second is a multiple of this number. Example: 66 is a multiple of 11. 44 is a multiple of 11. The difference between 66 and 44, which is equal to 22, is also a multiple of 11. Application: answer by true or false. 7 divides 21 and 7 is a divisor of 35. Then 7 is a divisor of 35 minus 21. To be able to solve this application, notice that this statement 7 divides 21 has the same meaning as 7 is a divisor of 21. Please pause this video to solve this application. This statement is true since 7 divides 21 and 7 is a divisor of 35, which means 21 is a multiple of 7 and 35 is a multiple of 7. By referring to property 2, we will obtain that the difference between 35 and 21 is a multiple of 7, which means 7 is a divisor of 35 minus 21. Property 3. P, Q, and R being three natural numbers. If P is a multiple of Q and Q is a multiple of R, then P is a multiple of R. Example: 234 is a multiple of 9. 9 is a multiple of 3. Then 234 is a multiple of 3. Application: answer by true or false. If x is divisible by 5, then x is divisible by 35. To be able to solve this application, note that x is divisible by 5 has the same meaning as x is a multiple of 5. Please pause this video to solve this application. This statement is false because if x is divisible by 5, then x is divisible by 35. This means that if x is a multiple of 5, then x is a multiple of 35. By referring to property 3, this means that 5 is a multiple of 35, which is false, since 5 is a divisor of 35. Prime numbers. Prime number less than 100. You are going to solve activity 3, page 57. Consider the 100 chart at the right. We circled the first 5 prime numbers 2, 3, 5, 7, and 11. Cross out all the numbers divisible by the first 5 primes. What can you say about the divisors of the numbers that are not crossed out? How many divisors are there for the numbers that are not crossed out? Please pause this video to solve this activity. Solution. The divisors of 13 are 1 and 13. Those of 17 are 1 and 17. The divisors of 19 are 1 and 19. And so on. We continue finding the divisors of the numbers that were not divisible by the first 5 prime numbers until we reach 97. All those numbers that were not crossed out have exactly 2 divisors. Definition: a prime number is a natural number that is greater than 1 and which has exactly 2 divisors, 1 and the number itself. A natural number that is greater than 1 and is not a prime is called a composite number. Example: 19 is a prime number and 22 is a composite number. Remark: 1 is neither prime nor composite. Now, how to find whether a number is a prime or composite? Use your calculator to divide successively the given number by the prime numbers 2, 3, 5, 7, etc. You will keep on dividing this number by the prime numbers until either you will reach a quotient with decimal point that is smaller than the divisor, which means this number is a prime number, or you will get a remainder of division which is equal to 0, which means the quotient is a natural number. This means that this number is a composite number. Example 1. 127 is a prime number. You start dividing 127 by 2, the first prime number. You will obtain a quotient with decimal point, which means the remainder is different than 0. Hence, the second case is not obtained. Looking for the first case, you compare the natural part of your quotient by the divisor you have chosen. 63 is bigger than 2, then the first case is not obtained. After that, you continue dividing 127 by the second prime number, which is 3. Then look if any of the 2 cases is obtained. Since neither of the 2 cases will be obtained yet, continue dividing 127 by the next prime numbers until you divide 127 by 13, where you will get a decimal quotient whose natural part is 9. Compared to the divisor, which is 13, we see that 9 is smaller than 13, which means that the quotient is smaller than the divisor. So you stop dividing and you say that 127 is a prime number since 9 is smaller than 13. Example 2. 119 is a composite number. You divide 119 by the first prime, which is 2. where you will get a decimal quotient whose natural part is greater than the divisor. So continue dividing 119 by the next prime numbers until you divide 119 by 7, where you will get a natural quotient, which means the remainder is 0. So you will say that 119 is a composite since 119 is divisible by 7. Application: show that 131 is a prime number. Pause this video to solve this application. Solution: 131 divided by 2 gives me a decimal quotient whose natural part is 65, which is greater than 2. Continue dividing 131 by 3, which gives me a decimal quotient whose natural part is 43, which is bigger than 3. So I should continue dividing 131 by the next prime number and check whether any of the two cases is obtained yet or not, until I divide 131 by 13, where I will get a decimal quotient whose natural part is 10, which is smaller than the divisor, that is 13. Then I say that 131 is a prime number since 10 is smaller than 13. Assignment: review pages 58 and 59 from the textbook. Homework: exercises 13, 15, and 21, page 64 from the textbook. Summing up: B, C, D, F, G, and K are natural numbers. Knowing that D equals B times C, we will get that D is a multiple of B and C. B and C are divisors of D. Properties: D is a multiple of C. B is a multiple of C, then D plus B is a multiple of C. D is a multiple of C. B is a multiple of C, then D minus B is a multiple of C. F is a multiple of G. G is a multiple of K, then F is a multiple of K. A prime number is divisible by 1 and itself only. A composite number has more than 2 divisors. 1 is neither prime nor composite. This is the end of the video. Thank you for watching. Goodbye.